Alright, last problem is number 9. We are using a significance level of 0.01. The claim that we are testing is that the single line causes lower variation among the waiting times. So sigma is less than the 6.2, the lower waiting times, and we have a sample of 25 customers. The sample standard deviation for those 25 customers is 3.8 minutes. Opposite of our claim is sigma is greater than or equal to. We're just going to write equals to. This is our alternative hypothesis, our null hypothesis. Alright, so we're going to use the var test in our program. Program var test. Hit enter. The variance we are testing is 6.2 squared. The sample size is 25. Sample variance is 3.8 squared, the sample standard deviation squared. The significance level is 0.01. Write down our test statistic, 9.02. 9.02. And the p-value, our critical value, is in the left tail, so we're going to use the smaller value, 0.0024. 0.0024. Again, our critical value is over here in the left tail. So we're going to compare this to the significance level, 0.01. And this is going to be less than 0.01, so we reject the null hypothesis. Our formal conclusion: there is, since we're rejecting, sufficient evidence to support, since our original claim is the alternative hypothesis, the claim that sigma is less than 6.2. And the critical value, we're going to use the equation solver. So we hit math, press up for the equation solver. The lower boundary again is 0. The degree of freedom is 1 less than the sample size, so we're going to enter 24. And the area under the curve between 0 and that critical value there is going to be 0.01. It's the significance level. So we just have left tail, so all this critical region right here, that area is 0.01. And we go back up to the U for upper boundary, hit alpha and enter. And that will give us our critical value, the value that corresponds to the value that's going to separate this shaded region from the non-shaded region. And that's 10.85 is that critical value. Alright, let's make this correction real quick. The significance level is not 0.01. It's for number 9. The significance level is actually 0.05. So 0.05 is our significance level. So let's finish the critical value first. So this area right here is 0.05, not 0.01. 0.05. Go back up to the upper boundary, alpha, enter. And the critical value we should have is 13.85. So 13.85. And then we should change this also to 0.05. And we would still reject the null hypothesis because the p-value is still less than the 0.05 significance level. We're all done with number 9.